Welcome! In this video, we are going to take a look at problem 52 from chapter 22 of College Physics 2E by OpenStax. Okay, so we have a segment of wire. It is supplying current to the motor of a submerged submarine. It carries 1,000 amps. And it feels a 4.00 Newton repulsive force from a parallel wire that's 5.00 centimeters away. We need to find the direction and magnitude of current in the other wire. Let's start with what we know. Okay, we know the length is 2.50 meters. We know the current, let's call it I1, is 1,000 amps. We know the magnetic force on I1 is 4.00 newtons. It is repulsive. This means that the other wire is in the opposite direction. You can see my video that answers why this is the case. But we do know the direction. Okay, we know the wires are 5.00 centimeters away, and we need to find I2. Okay, magnetic force between two wires is mu 0 I1 I2 L divided by 2 pi r. We need to solve this for I2. So we're going to have F times 2 pi r divided by mu 0 I1 and L. Okay, so we can substitute the numbers. Okay. F is 4.00 newtons. We have 2 pi, and then R is the distance between the two wires. That's the 5 centimeters. The length is in meters, so we need to convert R to meters. So we need to multiply it by 1 meter divided by 100 centimeters. Okay. We need to divide by mu 0. That's the permeability. It is 4 pi times 10 to the minus 7 Tesla meters per amps. We have I1 is 1,000 amps, and then the length is 2.50 meters. Okay, I did this calculation, and I got 400 amps. And then we can say the direction is opposite to I1. And that is because the force is repulsive. Okay, that's going to do it for that problem. I hope you found that helpful. Please let me know in the comments section if you have any questions or there are other problems you'd like to see me solve. Thank you for watching. Please like and subscribe, and I'll see you in the next one.